This question says, given an arithmetic sequence with initial term 11, so A1 is 11, a common difference of 7. We want to list the first 5 terms of that sequence. So each one goes up by 7. So what do we get? Again, A1 is 11. A2 would be 11 plus 7, which is 18. A3 would be 18 plus 7. Which is 25. A4 would be 25 plus 7, which is 32. And A5 would be 32 plus 7, which is 39. So in terms of listing elements of that sequence, 11, 18, 25, 32, 39. This is an arithmetic sequence. First 5 terms, I guess it goes on beyond that, but I just listed the first 5. 1, 2, 3, 4, 5. Common difference on each one is 7. Now, what's the next thing it asks us to do? We're supposed to find a formula for the nth term. So how do we find a sub n? Well, to find the third term, I take 2 steps of size 7. To find the fourth term, I take 3 steps of size 7. To find the fifth term, I take 4 steps. So to find the nth term, I don't take n steps, I take n minus 1 steps. So the nth term, we take n minus 1 steps. Each step is size 7. What am I starting with? I am starting with 11. So it should be 11 plus n minus 1 times 7 should be our nth term. So for example, let's try our fourth term. If we're going to check this, let's see what is a sub 4. A sub 4 is 11 plus, plug in a 4 for n, 4 minus 1 times 7, which is 11 plus 3 times 7, 21 plus 11, which is 32. So that matches, that checks that indeed this is going to be our nth term of our sequence. Now what can we do? What's the next thing that it wants us to do? It wants us to find a formula, or excuse me, to determine the sum as k goes from 1 to 50 of a sub k. So let's write that down. Sum as k goes from 1 to 50 of a sub k. All right. Well, my preference for this is to figure out what's the first and the last. So a sub 1 plus a sub n. That's my pair, and how many pairs do I have? Well, we know that a sub 1 is 11. We know that a sub 2 is 18. We know that a sub 3 is equal to 25. What about a sub 50? So plugging 50 in here, 11 plus 50 minus 1, 49 times 7. What is that going to give me? 11 plus 49 steps of size 7. 11 plus 49 times 7 is 354. How about A49? Starting at 11, and this time I take 48 steps of size 7. What's that going to give me? 11 plus 48 times 7 is 347. And how about A48? Starting with 11, I take 47 steps of size 7. 11 plus 47 times 7 is 340. But I want you to look at the pairs. First and last. First one is 11. Last one is 354. If I add those together, what do I get? 11 plus 354 is 365. Interesting number. How about the second and the second to last? Again, 18 plus 347 gives me 365 again. And third plus third to last, 25 plus 340, 365. So each pair is 365. How many pairs do I have? Well, there's 50 numbers in our list. If there's 50 numbers in our list, I would have 25 pairs. So the total should be 25 pairs of 365. So what is 25 times 365? We get 9125. We believe that's the answer, but I can also use this and this with the graphing calculator to get ourselves in a computation. So I see that a sub n is 11 plus n minus 1 times 7. So the sum as k goes from 1 to 50 of a sub k, sum as k goes from 1 to 50 of a sub k would be 11 plus, replacing n with k minus 1 times 7. So I'm going to feed this to the summation on the calculator and see if I get my answer of 9125. So let's go ahead and do that. We'll jump to the calculator and clear all of this. So I go to math. Num is, 0 is the summation command. K, so it's already in alpha mode, so K is here. K goes from 1 to 50. And then inside the parentheses, 11 plus, parentheses K minus 1 times 7, parentheses K, alpha K, minus 1, parentheses times 7. And we hope we get 9125. And sure enough, we get 9125.